Hi, this is Glenn Dane. I'm a professor in material science and engineering at Ohio State. What I want to do is introduce a series of lectures and the content that we put together that gives K-12 educators a little background in material science that can be used in classrooms, mostly for professional development. We also have material that will be linked can be directly used for your classrooms. Why material science? Well, this starts from a project that's been going on with ASM International and the ASM Materials Education Foundation. It really takes applied chemistry and builds it into products, takes that science, builds it into products through inquiry, experiential curricula, and it really integrates the natural STEM disciplines of science, technology, engineering, and math, and puts it together with low-cost demos that you can use in your classroom. It's shown to work very effectively in K-12 classrooms. ASM Materials Education Foundation has been very successful with this, and I encourage you to look into their camps if you are an educator. They're really great things. Been very popular with teachers and students alike. The content that's been put together by the ASM Materials Education Foundation looks like this. They go through solids, metals, ceramics and glasses, polymers and composites. We're going to take a little bit different tack, but we're basically going to use all of the example activities that ASM has put together. But what we're going to do is really focus more on the core science behind this, and then we'll link to the activities, hopefully put them into context. And loads of people have done good things in terms of using the activities, and we're going to let that stand as it is. The other thing that this does is this really goes right into science standards and curricula. This is what we do in Ohio. There's physical science that I'll show has loads of connections to material science. Then there's advanced sciences, chemistry, environmental science, some aspects of geology, and lots of physics link directly to material science as well, and we'll go through some of that. So this is what physical science looks like. That's usually taught in the 9th grade in Ohio. Big parts of this really couple very nicely to material science, particularly energy transformations, putting heat in to melt things, for example. Motion, somewhat, not quite as much, but forms of energy we can do a lot with. We can do a lot, obviously, with classifications of matter. We can motivate lots of chemistry, chemical reactions, interactions of matter, and this forms about half of the physical science content that happens in most any physical science curriculum. So the other part could be done with, for example, with motion and the universe. But the other ones that are circled all fit very nicely into material science, and that's another motivator for using this content. So here's what's going to be in this lecture series. This is in development. What we're doing right now represents the overview. Next topic up will be properties of materials. Then we'll talk about materials in the past and the future, what they've done for us, what they can do for us. Then we'll get into some of the meat, metals, ceramics, polymers, and composites. Talk about how they're made, what the structure is. There's some very specific atomic structures. We can change those structures by heating, cooling, doing other things through phase transformations. If we do that right, we can change the structure and engineer properties. That's the basis of manufacturing. Manufacturing, in broad sense, pulls stuff out of the ground, turns it into useful materials, and it might end up back in a landfill. That's what I call a material flow. All of that stuff we want to design carefully if we're going to be sustainable. This links to the ecology part and even the geology part of what we might like to teach in high school. And then the last part's a little special. What we want to do is acknowledge there's loads of great career paths in science, technology, engineering, and mathematics. Not all of them require bachelor's degrees. Loads of great professions in things like welding and other skilled trades. And then we'll also talk about how this curricula can fit into the standards that we use and develop full courses around it. There's lots of ways of using this. It can be the basis for a hands-on curriculum in studio arts or in things like welding. And of course, it can lead to PhDs and all the rest. So what we're going to do for each of these units back here, we're going to have an overview lecture. There'll be some professional development material, PowerPoints, movies, other links of more detailed things you can look for. We'll also have moderated discussions on how this might align with standards and be used in a classroom. And this up here really represents professional development. What's down here are things you can use in your classrooms, labs and demonstrations, movies, handouts, and then classroom support material like PowerPoints, tests, reading lists, and things like that. So that's really for class usage primarily. So the material we use, we're going to be advocating the use of creative content licenses, which basically means I've taken this from somewhere. This isn't highly original content on my part, and I fully expect people to take it, use it. Hopefully they'll grow on, they'll take it and extend it and give it back to the community better than it was. And that's a great way to move things along, and everybody wins, but nobody gets rich necessarily. So acknowledgement, again, this is based on a couple of things. The work of the ASM Materials Education Foundation. We also have a math science partnership grant in the state of Ohio that we are grateful for. We've got a team of people that are working on that. ASM Materials Education Foundation. Tom Stobie got this going years ago, did a lot of work, and then in recent years, Andy Neidham and Debbie Goodwin have put countless hours into refining much of this material. Local colleagues at Ohio State University developed a course called 205, now it's called 2010. And that's a course that all aspiring engineers take on materials, and we've used some funding from the Honda Partnership Program to do that. Hope you enjoy this series. It'll be coming up a bit at a time. This is just a quick overview, and thanks so much for being with us. We hope you participate and get some useful information out of this. Take care.